Okay, I'm hoping, geez, I should be able to. This is attempt number 2. Sadly, it says I'm recording. Okay, all right. Yeah, let's get into it, huh? Sorry about that. I thought I recorded and didn't record. Hey, real quick before we dive in, make sure you're getting those tests finished up, so I can get those graded in the grade book. I sent you the information for the next junk box war. You're building parachutes for eggs. It should be a little bit more straightforward. The cars are always challenging. These next couple are a little easier ones to accomplish. Um, nice job at hanging in there as we transition between different Schoology classes. I know it's been kind of ah a rocky start at times figuring out how this whole online school is working, but we appreciate you all doing your best to um, keep up with things every day. Speaking of keeping up with things, we have Unbalanced Forces today. And so we are going to be focusing on forces, once again, just like our last unit, only now there are forces that are in equilibrium. They are unbalanced. So let's dive into this thing. All right. Our formula that you're going to be using a ton again is thankfully an easier one, and that is force equals mass times acceleration. All right. So we know this one. Our only difference is now when we have forces that are acting against each other, we're looking for that net force. Okay, so the net force is the one that we want to find. So, for example, you read through this, but for example, a box that's pushed with a force of 60 newtons to the left, friction's opposing at 20 newtons. The net force um, that whole experiment is experiencing is 40 newtons. Okay, so that whole system is moving at 40 newtons because of the opposing forces there. Friction's another day. We're going to start off with an elevator. Okay, this is kind of it seems like a strange thing, but we've experienced elevators before and how they work. I'm going to pull up my calculator here to make sure that we are. You can see me doing some of the math on this one. It's a big calculator. Let's make it a skinny calculator. All right. So starting off, you have a mass of 75 kilograms and you're standing on a scale in an elevator. All right, let's go ahead. We know it's 75 times 9.8, which is the acceleration due to gravity. So we know that that scale is going to read 735 newtons. Okay, so 735 newtons. Starting from rest, the elevator accelerates at 2.0 meters per second squared for 2 seconds. Okay, who cares? It's for 2 seconds. What's the scale reading during that acceleration? So, mind you, it has to overcome this 735 and then accelerate you upwards at 2 meters per second. So, it's to overcome gravity and then some. So, what I'm going to do is I'm going to take that 75 kilograms times my 2 for acceleration 150, and then add that to the original 735 that we need just to overcome gravity. All right, so that's going to give us 885 newtons with the idea that we have to overcome that first bit and then accelerate after that. Part 2 there is compare that to what scale reads at rest. Well, we know it's 150 newtons more than just standing there and resting. That should make good sense because we don't need to we need to accelerate it upward. So it needs to be more than the force of gravity. Let's hop into our second example here. Okay, Chance standing on the bathroom scale and elevator at rest on the Sears Tower. Who cares what floor? The scale reads 836 newtons. Let's pull up Mr. Calculator. All right. 836 divided by 9.8 to figure out Chance's mass is 85.3. Good to know. So as the elevator moves up, the scale reading increases to 936. What is the acceleration there? Ooh, okay, so we get, I'm going to take the acceleration or the increase in force is 100, correct? 936 minus 836, that should be pretty straightforward. So 100 divided by 85.3. So that acceleration it experiences is 1.2 meters per second squared. All right. Second part, as the elevator reaches the floor, the scale reading drops. Okay, so it actually is below what gravity is. So it is letting gravity have its way a little bit there. So we're going to take that 836. Ooh, it's not an 836 divided by 7. Oh boy, struggling this morning, guys. Let's clear that. 836 minus 782. Here's our newtons divided by, I believe he was 85.3 kilograms. And so we get an acceleration of 0.6 as that thing's coming down to a stop there. Okay, so a couple elevator practice problems for you in the notes today. Check them out. Remember, there'll be an answer key posted the following day there.